Well, welcome back. Thanks for coming back. We're going to talk about more about Kotlin. So in the first part, we talked about functions. We talked about the language in general. And we talked about how to really create and loop through and things like that. Well, I want to move forward. We are talking about another feature here, which is pattern matching. I have to say this is one of my favorite features in a lot of different languages. In fact, Java will have this eventually. So there's these things that are extremely powerful in a lot of different languages, and Kotlin definitely provides that. So let's talk about what when is going to provide for us. All of us have written code with a lot of different if-else statement. Once we finish it, we never want to look at it again. It's that really stressful and awful. Well, this is where we can write code in a way that's pretty elegant. So let's say we have a process function we're going to call. I'm going to pass a bunch of values to it. So let's say these different values. And let's also pass, let's say, a hello. And then finally, why not, simply a string builder out of nowhere. So we want to call these different things into this process function. Well, first of all, we'll say input, and the type is going to be any in this case, not any specific type, because we can see that we are passing numbers and string builder. So the commonality between all of this is a type called any. You don't want to use too many of this any. That's not a good programming practice, but occasionally this can be really useful if you're receiving some message and you want to process it. So in this case, what I want to do to begin with is simply print the any. We'll start with that first. And we can see that in this case, it printed all those different values. Well, the string builder doesn't have any value really here. Whatever, let's go ahead and just pass that whatever to it. And you can see that that's the value that came through. But what I want to do here is to use pattern matching. So the way we're going to use pattern matching is when input. And this is where the beauty of pattern matching really comes in. And think about this like a coin sorter if you want to think about it. So you have different coins of different denomination, and you want to sort them. You want to maybe sort nickels away from dimes and so on. And so you want to really filter through and get the different values as they match. So in this case, I could say 1. And we will simply print out 1 here just to get a feel for it. So you can see that it extracted 1, completely threw away the rest of the values. But where it becomes really charming is the sheer power of this. So 7, 8, isn't that really beautiful? And you can simply print out a 7 or 8, for example, and you can see how it brings the value 7 and brings the value 8 into this for the value 7 and 8 that I provided. On the other hand, you can also say, for example, 13 to 19, and then we could simply print this out as, let's say, teens. And this is going to be the teen value, where 16, of course, is one of the teen values. So you can even provide a range of values and say in that particular range. And you can see the power of this shine through really nicely. You can also say is a string, and in this case, of course, you can simply print out we have a string. And you can see in this case how it is bringing in the string, and it says we have a string. And then finally, you can say else, and then you can print out no clue. I don't have a clue what I'm really dealing with at this point, and that would become a no clue. Well, not only can you do a very elegant pattern matching like this, but one of the things we can actually do here is, let's say we have a string, and I want to say of length, and I want to say that is a string of length, but how do I get the length value after all? Let's think about this for a minute. What is the type of input? The type of input is any. Let's talk about Java for just a minute. Let's say we are dealing with Java, and if you're dealing with Java, well, what would Java provide for you? Let's think about this for a second. Let's say we have an object obj coming in, and you say if obj is an instance of string, and once you ask for instance of, what do you normally do? Then you say, for example, output. We could say, for example, length, and then how do I get the length over here? You would have to say something. Can you say object.length like this? Well, no, right? What you have to do is you have to say string, and then you have to put object like this, and then you have to wrap this. Isn't that beautiful? Does anyone remember what this is called? Help me out here. You said casting. Actually, it's called punishment, right? That's what it is actually called. Because in this case, you're being punished for asking for the type and using it. But if you really think about it, I always ask this question. Do you work for the compiler, or does the compiler work for you? And this is something I always wonder, right? So in the case of Java, I feel like I work for the compiler. I have to do all of this and say, what do you think, compiler? And the compiler says, not enough, work harder. And I do more work, and then the compiler's like, okay, this is looking good for now, keep moving. And I don't want to be working for the compiler. I want the compiler to work for me. Well, good news is Java will eventually get this feature as well, but as we can see here in Kotlin, we can do this pretty effectively. So notice what I'm going to do here. I go to this code, a string of length, as you can see, but in this case, I put a little dollar and say input.length, just like that right there. Isn't that pretty beautiful? So it tells you the input is of length 5. You are able to call the length method on input because the variable input right here in this line has been already checked for the type of string. So the compiler knows very well that input is of type length. Make no mistake, if you go up here in the top of the function, and if you were to say right here something like input.length, you'll get the scolding that we deserve in this case, because that's not really a length property available on any type. But within here, it's a very different story because we already know that we are dealing with a string. So very sensible casting, auto casting, that is something really, really powerful, as you can see. So we can benefit from features like that to avoid ceremony in the code, and that removes a lot of those boilerplated code we keep writing, and that goes away naturally. Well, then comes along yet another thing. We sometimes run into accidentally returning null. Anyone here who really enjoys null pointers? Not really, right? Null is a smell. That's a 4-letter word after all. Nobody really likes it. And getting a null pointer exception is not fun at all. So how do you protect yourselves? Would be nice to know that you possibly are going to face a null. So let's talk about this with an example here. Let's say for a minute we are writing a function called nickname, and I'm going to pass a name to this function, and it's going to return for us a nickname for somebody. So in this case, the result is going to be a string. And what am I going to return right here? I'm going to say if the name is equal to, let's say, Robert, I want to return, in this case, let's just say Bob for a minute. What about if it is not Robert? I'm going to say, in this case, return. We'll say nothing for a minute. I'll come back and change this in just a second. So I'm going to go ahead and call this one and say nickname for, let's say, Robert. And in this case, of course, you would expect it to return a Bob, and it did. What about nickname for Venkat? I'm not aware of any useful nickname for Venkat, so it's going to say nothing. No, nothing is not a nickname for Venkat. I'm just saying it's nothing. But how do I really return the fact that there is no nickname for this? Oh, maybe I'll just return a null. I know that's a little ugly, but I want to say null. There's no nickname for that. But unfortunately, that would result in a blow up on our side, because what if you took the nickname and maybe used a function call on it, maybe to convert it to a different case, or maybe find the length, what have you? You don't want those nasty null pointer exceptions. Kotlin is going to protect us from that, as you can see. It says null cannot be a value of a non-null type string. So in other words, in Kotlin, types are things that cannot have a null, and that safeguards you already. So you cannot just arbitrarily send a null to certain types. What if you really want null? There are two ways to solve it. If you really want null, find a friend and ask for help. That's not a good programming practice. But if you still decide that null is what you really want, you can then provide a nullable type. So notice you put a little question mark next to the type, and now it permits a null value, as you can see. So by putting a question, this is a nullable type, and you're saying it's permissible to really return a null value in that case. But of course, there is a concern, though. If it's null, obviously, you don't want to call into methods into it and blow up. But how do you really get the values through it? Well, a nullable object, nullable type, protects you by requiring you to query for it to begin with. So to understand this a little bit better, let's pass null as a parameter and work with it in this example. Let's say receive is going to take a name over here, but I'm going to say it's a string, and I made it a nullable type, as you can see. I want to just print out the value of the name right here. So I'm going to call receive with, let's say, Joe, but I also want to call receive with nothing, a null value, as you can see. So when I run this little code, what is it going to do in this case? It is going to print out the name when I provide the name absolutely, but otherwise it said null. But I want to get the length of this. How do we really get the length of it? Well, I could do the following. First of all, if I tried name.length, this is not valid, because if the name is null, it's going to blow up, so it makes no sense. So the methods of string are not available on the nullable type of string. This will be a compilation error, as you can see. So error, only safe or non-null asserted values can be used. So you can use the double exclamation and stuff like that. But what I can also do here is I could query for this. I could say, for example, if name is not equal to null, then I could print out, in this case, name.length. Notice that auto casting again plays a role in this case. You don't have to worry about casting it. At this point, name is actually a string type, not a nullable string. On the other hand, you can say else. You can print out, let's go ahead and say, string size. Let's say size is 0. On the other hand, here I would print out, let's say, size is, and then we will say $1, and then we'll put that length over here. So when we run this, it says size is 3 versus size is 0. That worked. But we know this is quite verbose. There's got to be a better way to write this. And it turns out there actually is. We can be pretty smart about it once we get used to the syntax a little bit. So I can say, for example, size is, and in this case, what I can do is I can say name, and then rather than saying dot length, I'll say question dot length. So we are asking for the length. If it is available, use the length. If the length is not available, then give me a value of 0. So that becomes a very highly concise syntax, as you can see. So name question dot length. If the length is available, just give it to me. If the length is not available, then of course go further and give me the value 0 in this case. And that becomes a very nice way to process that, as you can see. So that becomes a very nice way to access the null object. A real quick little bit about functional style of programming. I'm a huge fan of functional style of programming because functional style of programming removes accidental complexity from code. It removes verbosity in the code. Let's talk about the difference between the two styles over here. So let's talk about, let's say numbers is equal to, and we will say list of. In this case, we will provide a bunch of values. Let's say all these values up to a value of 10. Now, what I want to do is to find the, let's say, total of the double of the even numbers. So how do you do that? First of all, var, you can see that's a smell of var already, mutable variable. And then you say result is equal to 0. And then you say for, let's say in this case, number coming from numbers. Well, that's a really nice little syntax. Then you say if number mod 2 is equal to 0, well, then, of course, I'm going to say result plus equal to number times 2. And then once we provide that value, we can print out the result. So when I run this code, you can see it is going to loop through all these values and provide the result for us. This style of coding is called the imperative style of coding. Kotlin certainly supports it. We all have done this for a long time. So what is this style? This is the imperative style of programming. In the imperative style of programming, you tell what to do and also how to do it. So you are responsible for both of those details. You tell what to do, but you also tell how to do it. The entire burden is on you to say every single step of the way. So this is a lot of work for us to write. Now, the problem here is this is a very low-level code. This is accidental complexity. I say accidental complexity because the problem doesn't require the solution. The solution brought on the complexity. The other smell in this code is mutability. We are mutating the variable result over and over and over, and parallelizing a code like this can be really hard in general when you have more mutability like this. Well, in the declarative style of programming, you are going to focus on tell what and not how. So you focus on telling what to do and not on how to do it. Well, that is the declarative style of programming. It's kind of like telling somebody, could I have a glass of water, please? You don't have to say how to get the water. They kind of figure it out. So you're being declarative, being directive rather than being imperative at that point. That begs the question, what in the world is then functional style of programming? Well, functional style is declarative plus the use of what are called higher order functions. So you're going to mix the declarative form where you tell what to do instead of how to do it, and then you mix with it a higher order functions. So we're going to do the job we did in the top, but we're going to do this with a declarative and a functional style. So to do this, what we will do here is we will say numbers dot, and in this case, we will go ahead and ask for a filter. And in this case, we will say given an element mod 2 is equal to 0. So we're getting all the even values from the collection, and then we can perform a map operation. Given an element, give me element times 2, and then we can simply perform a sum operation on it to get the value totaled in the very end. So when you run this code, what is this going to do? This is going to be providing us the functional style of code. So right there in the filter, we are passing a lambda to the filter, and then to the map, we are passing a lambda as well. And as a result, you can see it provides the value for us, which is the value of 60. For a more general purpose, you can also call a reduce method where you can say total comma element, and then of course in this case you can perform the operation for it. So total comma element, and you can say this is going to return total plus the element, which is the operation you are really interested in performing at this point. So that becomes a really elegant way for us to perform the functional style code. Now notice when you look at the code like this, this is involving mutability. It involves the loop. Oftentimes you write a for loop with a break and continue. And this is actually pretty ugly code. It becomes really, really hard. In fact, this is one of the things that really intrigues me. So one of the observations I have about imperative code is imperative is easy to write, hard to read. Well, once you write it, what happens for anybody who has to read it? Well, when you write a lot of imperative code, the people who read your code, they're not called programmers, they're called victims. And they have to suffer through the code afterwards, isn't it? On the other hand, a functional style code is hard to write, but easier to read. Well, that is kind of the flip of what we normally see in this approach. So one thing is really easy to write because we got decades of experience with it. We've been taught to write imperatively, but it takes more effort and energy and time to read imperative style code. Functional style code, we're not really that familiar with it. That's why it's a little hard to write it. I struggle with it quite a bit because I've done imperative style coding for 30 years, functional coding for maybe 10 plus years. So naturally I think imperatively, but I got to really work hard to think functionally. But once I write it though, it's a lot easier to read. It's easier to maintain as well. Well, the beauty is the Kotlin doesn't force you to do one way or the other. It gives you a choice. That's one of the reasons why it's a hybrid language. It tells you, choose your path, whichever you like. Imperative is better for you, use it. If you want to transform that to functional style and you want to refactor it, that's fine as well. You can pick and choose what may make sense for you depending on what you're trying to do. It doesn't really ask you to settle on one versus the other. So you can use these kinds of methods very nicely to write your code, as you can see. Then comes along a pretty intriguing facility. If you're used to C#, this is a lot like what you do in C#. Well, classes are always open. So for example, let's say you are creating a string. Let's say greet is equal to, let's say, hello. and I want to print out the greet right here, and you can see that we printed the greet right there. But what if I wanted to say greet.shout? Well, we all know that there is no shout method in the greet class. But hey, this is our code. We live in a free country. We can add anything we want to add, isn't it? It doesn't matter that we didn't write string. String is open as much as any class is open. So what you can do here is you can quietly come over to this code. As you can see, the shout doesn't work. It says unresolved reference shout. You can simply tell Kotlin, hey, Kotlin, the string class has a shout method, did you know? And the shout method is actually calling to uppercase method. Why don't you do that for me? So right now you introduced a method called shout. Make no mistake, this is not altering the class actually. This is a very nice compiler gimmick. So what the compiler does is, when you write extension methods, it keeps those extension methods separately on the side. And when you make a method call, it checks with the class to see if the method exists. If the method exists, that's great. If the method doesn't exist, it says, hey, look, I've got an extension method here. I'm going to go ahead and use it. Well, actually, in reality, it checks the extension method first, and if the extension doesn't exist, it checks with the class to see if the method exists and uses one or the other. So in this case, as you can see right here, you can actually provide the shout method very generously. So that didn't have any problem at all. But of course, if I call greet to lowercase right here, you can see that hello as a H uppercase, but the to lowercase printed everything in lowercase. Well, I was teaching this the other day, but you know how some developers are, they're overly excitable. So there's one developer in the room, he immediately raised the hand and he said, oh, this is awesome. And he didn't stop with that, he said, is it possible to redefine existing methods? Well, this is where you take the freedom to a great extreme. Why not? So notice the to lowercase is working right here, producing hello in lowercase, but you can go up here. I'm not suggesting you do, but you can say to lowercase is equal to uppercase. Now, if you run this code, notice that it produces lowercase and all uppercase. What really bothered me is not the fact that this can be done. What bothered me is how excited the developer was when he saw he could do this. Really dangerous. I don't know what's happening to him these days. But the point really is you can actually redefine functions that exist as well using extension methods, as you can see. I'm not suggesting you do this, but curiosity's sake, you can always say, hey, look, that's kind of funny, how I can actually take a method and redefine it to some other purpose. Again, it's metaprogramming. You can do that if you want to. But if you ever do this, don't tell anyone that I told you how to do this. So the point really is that it gives you the ability to provide these extension methods. And of course, it's not really part of the class, like I mentioned. Yeah, don't do this. You can see somebody sneezing already. That's not a good programming practice, causes allergy already. But the point really is that this gives you an ability to really extend existing classes. Well, that nicely brings us to the topic of object-oriented programming. So let's entertain the thought for just a minute. Let's say we want to create a class called car right there. I want to say val car is equal to car. You don't use the word new. You simply use the class as a factory, a constructor. So notice in this case, I'm going to just print out the car object. You may be surprised, but look at line number 1. That is the minimalistic car. You don't have to really go through any ceremony. You just created a class called car, and you're creating an object of the car right there. So you don't have to really put anything more, which really says you can start incrementally writing code. You don't have to throw a full boatload of boilerplate code in front of it. You can just grow it as you progress. So in this case, what I want to do is, first of all, before we even go any further, if I say class sports car, let's say sports car, and in this, I'm going to say colon car. Now, of course, the question is, where in the world did we get the colon from? Well, of course, we know in Java we normally use extends to perform inheritance. Well, languages like C# and C++ use colon, and so does languages that are similar to it. So in this case, we are using a colon to say it's inheritance. But the point really is classes actually are closed by default. Notice it says this type is final, so it cannot be inherited from, and the error is on the car, as you can see. If you really want to use inheritance, you have to open the class. We'll talk about this a little later on, but just that to say that the classes are final by default. Just like how string is final, you cannot inherit from string. All classes you create are final unless otherwise you say otherwise. It's actually defined to be final as a default. Well, in this case, we are going to create a car class, but within the car class, I'm going to say var. Let's call this as, year, let's say year of registration. So registration is equal to, let's go ahead and define it as a value of 2010 for a minute. So if I ask for year of registration, you can see that it's a value of 2010. However, I can start defining a few different things. This might appear a little odd to you, but if you're familiar with C#, this becomes a little bit easier to understand what they are doing here, because this idea is very much like what's in C#, not exactly syntactically, but more of the nature of how it is actually working. So in this case, I say val, let's say year since registration. And in this case, I'm going to write a method for this. So get, and the getter method I'm going to write is going to be 2018 minus the year of registration. Now notice how beautifully I can call year since registration, and it tells us that the year since registration is 8 years. So you're able to write a getter method for it. Again, syntactically, this may bother you a little bit, but you write a property, but right next to the property, you provide a getter for the property and a setter for it if you really choose to. Similarly, what if I were to go here and say car.year of registration is equal to 2015? Well, I'm changing the registration to 2015. Then I'm going to ask for car.year since registration. Obviously, that changes from 8 years to 3 years, as you would expect. But there is a problem here, however. What if I were to say car.year of registration is equal to 2020? Well, that is moving to the future, and maybe you don't want to permit that. In this case, of course, it will set it to the value because we made it as a setter, well, as a var. So as a result, it became -2, which is not really good. So what do you do to prevent it? What you can do here is you can write a set method where the set will take a value as a parameter, and within this you can say if. And then you can specify the value is greater than 2018. Obviously, I'm hard coding 2018, but typically you would get the current year during execution and make it fairly dynamic. Then what can you do? Then you can say if value is greater than 2018, then I want to say throw runtime exception, and I'm going to say year cannot be, so can't be in the future. So I'm going to blow up if the value is that. But if the value is not into the future, what do I want to do? A field is equal to value. Well, notice the word field. So the word field refers to the field for which you are writing the setter or the getter for that matter. So this becomes an automatic variable referent to that particular field that you are using in the code. So as a result, you can see we were able to set it to 2015, but we are not able to set it to 2020 because that's in the future, and year cannot be in the future, it blows up. So this is an example of how you can create the properties within the classes. If you don't want all these flexibilities to create a property with the getters and setters, you can be done with all of that. And you can go up here and say, for example, color, for example, string, and you can simply create the constructor with the value right there during construction as a parenthesis, like you are writing a constructor right at that point. Then you can, of course, create a car object with orange, let's say, for example. Then I can print out right here the car object that we just created. And then, of course, you can also ask for car.color because that's a val you can read it, but you cannot change it. And you can see the color of the car is orange, and you're able to get to it fairly easily. So we talked about the properties that go with the classes. We talked about the backing fields. The field is the name of it. We can also create the setter, but you can make the setter private by putting the word private in front of the set. You cannot then set it from the outside. You can provide the setters also. Well, the classes are pretty different from how we are used to in Java, isn't it? It's just a question of getting used to it. Maybe spend an afternoon with it. It becomes a lot more easier. If you have programmed in languages like Scala and programmed in languages like C#, it becomes a lot more natural for it. That's one of the things for me is, as I mentioned earlier in the previous presentation, I program in about 12 different languages. So it was not much of an effort for me to learn Kotlin. I kind of spent most of my time looking at this and saying, oh, this is like C#, that's like JavaScript, that's like Ruby, that's like Python. So it's more of an association to what I already know. And the only challenge is to kind of remember which language syntax are similar to which language they are, more close for a particular feature. But it's not really that much of a learning curve if you are familiar with other languages. If not, just question of spending a little bit of time before you get really comfortable with it. Well, then, of course, I'm going to talk about static methods. Well, if you want to purely create a class with static methods, then you can create a separate class for that. So I'm going to say object right now, util, and within this object, I'm going to create a function, and this is going to be called as get number. Let's call it as number of processors, and this is going to be equal to runtime.getRuntime, and then I'm going to simply say dot available processors. So now what I can do in the code is simply ask for util.number of processors, and I'm able to just access that static method. So if you want a class with only static methods and no instance methods, create an object, and that becomes a companion class that you can use pretty easily. But that's where all the static stuff goes into. Notice we said uppercase U, util.number of processors. We didn't put a parenthesis to create an object. Well, on the other hand, if you were to try to do a util with a parenthesis, this is an object, so automatically it's a singleton. That's what it really is. So you're not allowed to create an object of util because util is a singleton. You cannot create objects of it. There's only one instance of that, which is the object itself. On the other hand, you can also create static methods within classes as well. But for that, let's look at a method before we go with it. So class car again, but let's write a method called drive. And in this case, we'll take a distance of some type integer. And within this, we can simply print out, let's go ahead and say driving distance. And then we will simply print out the distance that's given to us, whatever that is, kilometers, miles, depending on the part of the world you live in. So in this case, of course, I'm going to say car equal to car. And then, of course, I can simply say car.drive over here and pass a value of 10 to it. And this becomes, of course, an easy way to call that method. This is an instance method as you see it, because I created an object of car, call the method on the car object. No surprises over there. On the other hand, if I really wanted to, I could go back over here and create a static method on this as well. So in this case, I'm going to create an object, a companion over here, and the companion I'm going to create over here companion, and this companion is going to have, let's say, a method called kind, and all I'm going to return is electric from here. So this is going to simply say it's an electric car type. So how would I really use it? So I can say car.kind. I can call the method on the object directly. And this is basically the kind method I can call on the object when I'm interested in calling this on this particular object. So this is going to be the companion object that I want to call into. I'm throwing a blank here on the syntax, but you're basically writing a companion object. On the other hand, if you are really interested in calling this method, you cannot create an object on it and call the method. You would have to just call it on the class itself. You'll get an error if you call this on an object. So that gives us an idea. But there's also a class called the data classes. What's the difference between a data class versus a regular class per se? Well, just to illustrate the point, if I say a person class, let's say val is going to be first, which is a string, and val is going to be, let's say, last, which is a string. Well, I wrote it as a regular class in this case. I'm going to go ahead and print it out. We'll go ahead and call this as Peter for a minute. Well, what in the world is Peter right now? So Peter equal to, let's say, person. We'll say here is Peter, comma, Parker. And I'm going to print it out. Notice we don't get any intelligent information when we print out Peter. Well, that is just a class. When you create a class, you're on your own. You got to write quite a few things. However, if you create a data class, then you get buy one, get many free. You get the equals method, you get the toString method, you get a component. All this is given for you free. So by putting the word data, notice we already have some meta information filled into it, so that becomes a lot easier to work with. Similarly, if I simply call this as a class, and if I were to print out Peter dot, let's say, toString, as you would expect in this case, the toString method is not really providing much help at all. But on the other hand, if I say a data class, you can see that the toString is pretty rich. That's exactly what we got when we printed the Peter as well. But similarly, we can do another very beautiful thing here. JavaScript has a feature called destructuring. Destructuring is pretty awesome, and you can do the destructuring here also. So first comma last is equal to Peter, and then of course in this case I want to simply print out the first. So we got a local variable called Peter first, and so you can do destructuring with this. That's again part of the data class. If you don't create a data class and regular class, if you will, notice that that doesn't really work for us. So the data classes can provide that for us. They even provide us a beautiful destructuring for us as well, which can really remove the ceremony in the code quite a bit. And you can also access the element you are interested in accessing by using a special method called component1, component2, and so on. And finally, a quick note about inheritance. Well, inheritance, you can do that pretty effectively here as well. So for example, if I really wanted to, I can say class, we can say, let's say cool person. And in this case, cool person is going to inherit from, so in this case, we'll say first, which is a string, and last, which is a string as well. But again, colon person, and you pass the first and the last over here. And then within the class, you can write a constructor, and the constructor takes a first, which is a string, and a last, which is a string. But I'm also going to pass to this an index, which is an int also. But within this method, what I can do here is I can pass this as a parameter to the constructor by saying first and last, and then I can say coolness index. Let's say coolness index is equal to the given value of index var, where I can say var coolness index, which is going to be an integer type, and you can do this. But keep in mind, classes are not open by default. So in this case, we get an error because we haven't opened the class called person, and you have to really open the class person for you to be able to provide that. So given this, that we are able to open the person, what I can then do here is that we can start using this in our code. So what do I do to provide this? In this case, of course, we want to pass this to the class. So we'll say this and then first comma last. So this is where we are passing the data to the constructor. So this is a lot like what Scala does actually in terms of bubbling that up to the base. Then of course I can say, let's say Alan is equal to a cool person. We'll just say Alan, and then of course Turing, and then we'll say the index is all the way to the 10. And we can of course print out, let's say Alan for a minute. Well, obviously, in this case, you want to override the toString method. Well, for that purpose, you can say override toString. And all this is going to do is to simply return, let's say, the first and the last, if you will. So as you can see here, we are returning the first and the last. So all it's going to really print is that. But we can then override it even further by saying override, and then we can say toString is equal to, and this of course becomes a super.toString, and then followed by, we can specify the coolness index right there, and when you print it out, it prints that value also. So a lot of things we know already in terms of override and super, a few things that are different from the Java point of view, but like I said earlier, if you're familiar with Scala, this is a lot like what you do in Scala. So I'm just gleaning into my Scala experience when I'm writing this. So that's kind of what I do in my mind is when I'm writing Kotlin, I just think of this other language syntax it relates to, and naturally it follows through at that point. That becomes really easy if you're familiar. Otherwise, you have to just go ahead and learn that syntax, if you will. I want to talk about two other ideas which are pretty powerful. One of them is laziness. Real quick, I'll mention about laziness. So let's say we have a function called compute, where the compute function is going to take, let's say, a value of int, and all I'm going to do here is simply say called right here, and then I'm going to simply return, let's go ahead and return the value n itself. So not a big deal. Now I'm going to say x is equal to 4. If x is greater than 5 and the compute of, let's say, 4 is greater than 7, I want to simply print out, let's say, result. When I run this code, obviously, it's not going to print that value. But in this case, we'll go ahead and print out just a little dash, if you will, after this. So what is this really going to provide for us? Let's iron through the error before we go any further. So unresolved reference, well, it's complaining about the greater than 7. So this is going to be an integer value. We'll just say int right here. Let's actually return the value n given to us just for now. And so this is going to be the value of n is greater than 7. It did not call the compute method, which is kind of obvious. On the other hand, of course, if I said 14, you would expect that to call the compute method, and it did. But the question really is, it's not calling the compute. That's awesome. But what if I were to take this code right here, and I say temp right now, and I say temp is equal to compute? Well, remember, just a second ago before I did this, when I ran this code, it's not calling the compute, which is awesome. But with the change I made, putting into the temp, when I run this, how sad it's actually calling the compute method, which is of no use at all because we're not using temp. Well, if you know this, what you can do is you can then say val temp by lazy, and you can wrap it around a lazy evaluation like this. And at this point, if the temp is not being used, it doesn't call it. On the other hand, if the temp will be used, you can see, then lazily it is going to call it. But where is it really going to call? Well, if you say, for example, here, you will notice that it goes past the here and then calls the called. So it waits until the value is actually used and postpones until that time. So this can be really powerful. But what I want to really show you now is some beautiful way to create a DSL, but let's introduce a bit of a fluency. There are some limitations to this in Kotlin, but nevertheless, it's pretty powerful. Let's create a class called pizza. Well, the class pizza contains a method called spread, and this takes an item, which is going to be a string, and all I'm going to do is simply print out, let's say, spreading, and this is going to be item, whatever that item is. So we'll just say item. Well, now I want to call this. So val pizza is equal to, let's go ahead and create an object of pizza. Pizza.spread, in this case, will spread some sauce, if you will. And then finally, we'll also pizza.spread, and this is going to be spread. So this is spreading, and let's just rename this as spread. And what am I going to spread here? Cheese on it. Well, okay. So when I run this code, you can see that it's going to provide those two. But the code is very traditional. The only thing that's missing is the ugly semicolon, isn't it? Otherwise, this is as bad as everything else we write. Wouldn't it be really nice if we can write it this way, where we don't put a dot, where we don't put a parenthesis, where we don't have to close this? Wouldn't that be so awesome? Well, sadly, it doesn't work. So what do we do about it? Well, notice it gives you a clue. It says infix modifier is required, and that is the answer. You just say infix right there. And now you can see how that beautiful syntax actually works. So that becomes an infix notation, and this can lead to some really powerful code, if you will, where you can write some beautiful, lightweight code. This is where I get excited, where I can stretch the language. So I'm going to walk through a little bit of an example where we're going to do something really fancy here. So let's create a class called robot. And the robot class contains two methods. I'm going to create a function called turns, and the turns takes a direction, which is a string. And all I'm going to do simply is print out, let's say, let's call it as turns, and then we'll put the direction. I'll also write one other method right here. We will call it as runs, and we will say speed, and speed is a string as well. And I'm going to simply say runs, and then I'll just print out the speed right here. Well, so far so good. Let's go ahead and say val robot is equal to robot. And now I'm going to say robot dot, let's say turns, and we will say left right here. And then we will also say robot dot, let's go ahead and say turns right. And finally, robot dot runs, let's say fast. Okay, that's a traditional code, nothing exciting, nothing to celebrate. But we know we can do this already. We can remove this dot from here. We can remove this parenthesis from here. And then we can also remove the parenthesis from the end. And of course, for this to work, we already know what the answer is. We're going to simply mark this as infix, and we're going to mark this as infix as well. So we kind of made a little bit of an improvement. But we are not here for that, right? We want something better now than what we just did. Why don't we take one more step? Let's go ahead and say operate. And operate is a function we're going to create. And what does operate take? It takes a function as a parameter. Now, this is a function that takes another function as a parameter. And what am I going to pass to this? A robot, of course, the robot. And the robot is going to be a type of robot. But then this function is going to return a void, a unit. So that's our operate function. Yay, that's great so far. But what are we going to do within this function? We will create a robot right within that function, then call the function and pass a robot to it, right? So operate is creating a robot and then calling the given function. Well, okay, so that's pretty easy. Now I can say operate right here. And what am I going to pass to the operate method? A function, of course, which means it's a lambda. So I can say, given a robot, then I can come down here and we can simply pass this over here and run it like this. Hey, that's kind of nice. The syntax is a little bit more elegant. So when I run the code, you can see that produced that result after all. But wouldn't it be nice if we can reduce the ceremony just a little bit? Well, here comes the charm. In the case we called it as robot, but we could call it whatever we want to call it. Programmers who are really way smarter than me will call it as K or W or Z, isn't it? So we can give all kinds of ridiculous names. But if you're going to give ridiculous names, why not just simply be done with it? And we can simply say it. Well, that's nice. This it is the object that's being passed to this robot. So that's really great. Now that becomes really fluent. Well, almost fluent. You say, wait a minute, Venkat, but I don't like this left. Wouldn't it be so beautiful if you can say left right here and right here? And then if you can even say fast over here, wouldn't that be really cool? That would be really cool, but it wouldn't work. So what do we do about it? Well, let's go back over here and say val left is equal to left. It doesn't have to be in this class. It could be from somewhere else as well. Right is equal to right, and then fast is equal to fast. But before we move forward with it, let's talk about what we are trying to really do. What we really want to do is we could do something like this, isn't it? It.left, it.right, it.fast. So it's pulling the data from it. But I know you're not happy with it. I couldn't see the smile on your face. You're like, gosh, that's smelly, Venkat. Come on, we came here for something better. Okay, fine. Let's talk about something else before we go further with this. That doesn't work. But let's step back. We'll come back to this in a minute. I know it's really scary when I say we can learn something from JavaScript, but truly we can. So if I were to write a method in JavaScript, let's say in this case, constant greet is equal to a function name. And in this case, I want to print out, let's say a dollar, let's say in this case, a dollar this, and then dollar name. What in the world is that this? Well, you can say greet.call, and I can say hello, comma, Joe. And notice how in this case, that particular this is being bound to the first argument of call. So it says, hello, Joe. So this is a feature of JavaScript where when you call a method with a call, this will be bound to that first argument. Well, Kotlin has exactly the same concept, except they don't call it call. So notice what I'm going to do here. I go to this function, and I turn this function to run in the context of robot. Now you can put whatever you want to put here. Whatever you put there, it'll run in that context. Here's how you read the syntax. It says, I have a function. That function takes one argument, but that function itself has an implicit this, which is of type that. So the format of this is you can say implicit this type dot and then parenthesis parameters, right? So this is basically the type of the syntax. You provide that. Now remember what you did in the call method. In the call method, you were able to pass the robot as the first argument the this. So notice what I'm going to do. I passed robot and robot. So what did it really do at this point? It took this robot for this, and it took that robot as an implicit object. So when it found something it doesn't know what to do, it automatically calls on this. Well, okay, that worked, but maybe we can do a little bit better here. Why not simply say, after all, this is a context object, so we'll say robot.function robot, and there you have it, a beautiful syntax which is able to run that, and that is a little DSL using the inflex, and we are able to create something pretty powerful, as you can see, and here is the full code for it, as you can see in here. So you can see the power of the language. Its fluency, it's expressive, and of course, it feels a lot natural. It does borrow a syntax and semantics from a lot of different languages, but of course, that may involve a little bit of a steep learning curve if you're not familiar with those other languages, but if you're familiar with a few different languages on the JVM, you'll feel quite at home programming with this. So that's basically a quick rundown of what this language can do and the power it has. If you're interested in downloading the code examples, please feel free to download them from my website. There's the downloads link. Feel free to take a photo of it if you're interested. Hope that was useful. Thank you.